Stat E 9.3. Confidence interval decisions. Basically, this is a follow-up question. Once we've created our confidence interval and we've interpreted it, I might ask you a follow-up question in regards to seeing, can we make a decision on something being true or false, or how do we go about doing it? So we know our normal problem is to create and interpret a blank percent confidence interval. Some C. All right. That's the most common question. That's what we've been doing. We've been doing this multiple times. You should know that when you do this, you should know the steps that you do within each one of these. Step 1, we check the assumptions, which means we're going to use SIN, just like we did in the do now. We're checking SIN, making sure that they're reasonable to say that they're good enough. Maybe some assumptions in there, check them off, and again, what that means is that therefore the mean distribution of sample proportions is approximately normal. Step 2, the thing that we're doing is we're going to find the interval, which means we are going to use the formula p hat plus or minus z star times the square root of p hat 1 minus p hat over n. Now remember, as we've been practicing in your homework in our do nows, we do the minus first and then we do the plus. As we've also noticed, for some of you, it might be easier to first find out what the standard error is, which is that square root, as a decimal, and then do it like we did the do now. When we do this, we're going to get some interval A to B. Okay. Then 3, we are going to interpret the interval. And this is when we write down we are blank percent, whatever that's C, confident, ... That's where we write that sentence, okay? Remember, you should look and make sure you're talking about the correct population. The biggest mistake I get on some of these is, again, careful with the tense that you use. If you use past tense, how many students were able to reproduce? Able to reproduce was talking about the sample, the 49 out of 207. We want to know about the population, the unknown. How many will be able to conceive? How many will be able to reproduce? Careful on that. And once we've done all that, we can now move forward to this new follow-up question. Okay. And what this happens in regards to it, it goes something like, based on the interval, is there evidence that blank is blank then blank? And what these blanks are is it P, the parameter, is more, I might say the word more, I might say the word less than PO. And of course I know you're asking, well, what in the world is PO? PO is what we refer to as the hypothesized proportion. Also just known as, it's the claim. Basically, somebody makes a claim. I say that it is this. I say that, and this is what happened in the do now. They have a claim. I claim that you're going to get at least 25% reproductivity. All right? So if you come in, if you don't get at least 25%, you're going to be upset. If you got 26%, if the company is actually helping 28%, you're going to be kind. You're not going to argue, right? So if their claim is 25% of women are going to be conceiving after help through the clinic, and the answer is actually more, then you're going to be okay with that. So really, we're saying 25 or more is their claim. So what you're looking for, is there evidence that it's less than 25%? Is there evidence that it is actually under 25%? Well, your p hat in that problem was less. So that's some evidence. But what we do is, the answer is yes, there's evidence of being wrong since blank PO is not in the interval. Or the answer, this is an or, the answer is no. There is no evidence of being wrong since blank PO is within the interval. Now, what I want to say, please note, answer the question. So what I noticed, and maybe I didn't do a good job in fully going over it with the last class, answer the question. So just because you said no or interval, what is the question actually asking? All right, so a lot of times this is what happens in the real world. We'll only do something if there's more than 2% or more than a certain percentage. If more than 20% of students are reacting positively to like a new method of teaching, then I'll introduce that. But if I had to spend all this time writing up the code to a Desmos and seeing if it was working, okay, and if I'm doing that and less than 20% of students, well, less than like 50%, are not responding, then why am I going to waste my time developing all that work if it's not working from the students? So I'm looking for evidence that at least, you'll say 20% of students. So therefore, if the entire interval, I want the entire interval to be above 20%, in other words. So is there evidence that more than 20%? Well, that's only true, yes, if the entire thing. Now, I'm not asking you, is 20%? I'm asking you if there's evidence of more than 20%, which is a little bit different of asking. So in the do now, my interval was 0.1678 and 0.3055. My PO, my hypothesize was 25%, which was 0.25. And so my question here is there evidence, and I'll word it more like this when it comes to the exam and the practice, is there evidence that P is less than 25%? Is there evidence that P is less than 25%? Okay. And my answer to this question would be, what do you think it is? Yes or no? Is there evidence, based on this interval, is there evidence that the actual P is less than 25%? The answer is no. The entire interval is not less than 25%. So in order for there to be evidence of it's under 25%, the entire interval needs to be less than 25%. Now, is less than 25% possible? Yes, my confidence interval says yes. It is possible my interval contains values below, but my interval also contains values above. So can I disprove 25% being the true answer? And the answer is no. I can't say, you liar, it's not 25% or more, because 25% seems to be the truth. That's what I have for you.